All right, so good news is that if you found the previous lessons not challenging, here's your challenge. So when we are factoring trinomials in the form of ax squared plus bx plus c, now the only thing that is different here, now I would like to call this case 3. So case 3 here is we have our coefficient in front of x squared is not 1, is a non-1. Well, actually, in fact, it can be 1 as well. This sort of factoring method does help. So I'm just going to move over to the side here. And I'm just going to say, what did we learn in case 1? And it was factoring out common factors. So, for instance, if we had 3x plus 3, we could take a look. Oh, we have a common factor of 3, so we factor out 3 from both terms. Also, we could have 27x squared plus 9x. This is a binomial. You may be able to spot out, oh, wait a second, we have a greatest common factor of 9x, so you'd factor out 9x. And remember, factoring out is very similar to dividing, and this common factor process is a lot of what we're going to do today. So anyways, you'd factor out the common factor, there we have it. Now, case 2, well, I would call this case 2. So case 2 was when we had something in this form, where we have x squared plus bx plus c, and we would use the sum product rule. But in order to do this, you need to make sure that your coefficient in front of the x squared was 1. So, which was different than case 1. Case 1, you just have to make sure that there's common factors that exist. Case 2, well, sum product rule, and so for instance, x squared plus 7x plus 12, you could easily factor this using the sum product rule, that we're going to simply split this up and ask ourselves, what two numbers multiply to 12 but add to 7? And that's 3 and 4. All right, so that's case 2. Case 3, case 3 now, what we're going to be investigating today is when the coefficient in front of the x squared is a non-1, or it may differ from 1. Now, I better be careful here. There. So, for instance, you could factor 2x squared plus x minus 1. If you take a look, can you use case 1? No, because there's no greatest common factor exists between all the terms. Can you use the sum product rule? Well, no, but simply because the coefficient in front of the x squared is 2. So we're forced to use this far more robust case of factoring. So without any delay, let us begin to factor.